Hi, I'm Andrea Angella, and in this video we are going to do the paper 4 for A2 level computing of October-November 2015. And let's start. Okay, the first question is, so we need to pick a programming language to use. We are going to use Python. That is the most common language used. Python. We have a large software house has been asked to supply a computerized solution for a business, and we have a list of activities and a description of each activities and how long each week takes to complete. And we have been given a Gantt chart. So a Gantt chart is basically a chart that shows how each activity is performed and in which week is actually performed, so that you can actually understand when a particular project is actually can be completed. So how far in the future can be completed. So you can see, for example, here from this Gantt chart that activity A takes a week to do and is actually done at the beginning. Then afterward, the activity B occurs in the week 2. And then you can see that, for example, the activity C and activity H happen at the same time. As you can see that the activity C, for example, is writing the module code, and the activity H is actually researching and order hardware. So, of course, there are some activities that can be done in parallel by different people, different teams, and it's actually quite efficient to be able to do them in parallel, so that you can actually complete the project in a shorter period of time. But obviously not all the activities can be done in parallel. So the Gantt chart helps you to see these relationships between activities and help to plan how these activities can be performed and assign the activities to actually people or teams. So we have been given a Gantt chart, but this is not complete. So we need to actually complete it, complete the Gantt chart, adding the activities M and N. So let's have a look at what these two activities are. So M is training users on the installed hardware and software, and takes a week. And N is signing off the final system. That usually is, at the end of the project. So when everything has been delivered, including the training, you sign off the system. So M need to happen before N. So we have the Gantt chart here. We see that the last activities of the course are G and L. And you can see that G is basically the installing the software and carry out acceptance testing, while L is writing the user training guide. Okay, it's probably, it probably makes sense to train the users as soon as the software passed all the acceptance testing and when we have the documentation. So this activity makes sense to be done, afterward. So let me take the pencil, for example, so I can actually fill this in. Oh, let me take the color to be like that. So let me just color this to, okay, just fill it in. Oh, I have a problem with the mouse. That's not working. Sorry. Okay. Oops. So I can fill this in. It's probably easier doing that with a. Let's do with that. Let's fill it with. So M will be done in the weeks at the week 17, and N will be done at the week afterward. So here we do N. All right. So basically, then the next question is actually how many weeks actually the project takes. So what is the earliest completion date? Is that definitely 18 weeks. So we can actually put the result here and say 18. Perfect. Then we there are some problems. Obviously, any project never works as expected. There are always imprevised and things that can happen. So what happened is the activity E showed that the code contains some errors, and the senior programmer now do another estimation. So at the activity E that is completed at week 12. So after 12 weeks, there is a new estimation because there's been some errors. So the further module coding will be required another 2 weeks. The further module testing will be required another 2 weeks. in the further integration testing, we require another 2 weeks. And the hardware delivery is delayed by 16 weeks. Oh my God. All right. So we need to actually update the Gantt chart as in order to satisfy these new requirements. So let's have a look. So we have age and A, B, C, D, E happening. And so let's see what we need to do. We need to do so module coding. Let's see which letters are them. So module coding is C. Okay, so this one is basically the activity C. Module testing is the activity D. Okay, so this is D. And further integration testing is the activity E, integration testing. Okay, so this is just for our help. Okay, so we need to do basically we know that we need to do another as soon as after the week 12. So we know that we need to do 2 weeks of coding. So let me do that here. So we know we need to do 2 weeks of coding here. We also know we need to do 2 weeks of testing and then 2 weeks of integration testing. As you can see here, you can see that the last 2 bits of coding overlapped with the 2 bits of testing. So we could do the same here. And let's do that. And then also we need to do the integration testing that always occurs after the further module testing, of course. So we need to do this. This basically is the delay as what the senior programmer estimates. So this is our basically 5 weeks additional coding and testing required. Okay, so then we know that we need to compare this with the previous things. So what we know also, we know that the hardware delivery is delayed by 16 weeks. So before, J was the installed delivery hardware, but we can't install it, of course, because the hardware is not being delivered yet. So we need to, the hardware delivery is delayed by 16 weeks. So we need to install it 16 weeks afterwards. So you can see that in J, we start at week 4. So we need to do 4 plus 16, that is week 20. So we will start installing delivered hardware at week 20. So this means that at week 20, I already have that, activity J will happen at week 20. And it's still going to take 3 days in order to do the actual task J. Then what are the tests? What are the activities are missing? So we need to see what to do with activity F. So F is done after integration testing. This is, in fact, is actually alpha testing. So we can just do it straight after the integration testing, that is E. So we can just do that straight there. Then what we have G, that is G is installing software and carry out acceptance testing. So we need to do that after obviously having the hardware, because it's not possible to do acceptance testing. That means actually testing the full system with software and hardware together, by the users. So in order to do that, we need to have the hardware. So there is no way we can do that G straight after the F. We need to actually have the hardware. So we know that we need to do that after J. So we need to do that here. J is finished at week 22. So starting week 23, we can do G. And we know this takes 2 days. Okay, so we have done age, we have done J. We need to do K, L, M, and N. So K, key, is write technical documentation. So before, the key was actually starting when E was starting, and there is nothing stopping us to do that because this is just writing documentation. So I think we should be able to just start K at the same time. We know that it takes 4 weeks to do the documentation, so we can do K week 16 for other 4 weeks, like that. Then L. L is writing the user training guide. So in the original Gantt chart was happening after K, but let's have a look. L is actually writing the user training guide. So it's we can actually do it just after the same time when we do the installing software and carry out acceptance testing. So this is going to take about two weeks. So it's actually required to have the hardware probably to do this, because it's sometimes you need to actually not to write documentation, you need to explain how to configure the hardware, for example, to run the system. So, and actually to do the acceptance testing. So let's put the L at weeks. What is it? At weeks after the hardware delivery. That is actually week 23. So this is going to take 2 weeks. Okay. And then we still can do M and then as we done before. Just after that, we can just do 1 week M and 1 week N. So basically, we delay the entire system by 8 days. So the new week, estimated weeks of delivery is 26 weeks. All right. So even if the estimation of the senior programmer was about 6 weeks longer, and the hardware delivery is actually 16 weeks later, we only gonna deliver 8 weeks later. That's not that's better than 16 weeks for sure. So this is actually the new Gantt chart that you were asked to do. Okay. So the next question number 2, is about the other declarative programming language. So we have a bunch of facts and rules. So we know that we have Ahmed, Ro, and Ali, and Philip that are males. We have Aisha, Gina, and Mina that are females. We have a parent relationship between Ahmed and Ro. So we know that Ahmed is a parent of Ro, and so on. We have also the mother that is defined as a rule, that is defined that if A is mother of B, if A is a female, and is a parent of A is parent of B. So we have these rules and facts. We want to include more facts. So first of all, we want to include Ali and Mina are the parents of Ahmed. And we need to write these additional things. So let me take the text here. So we know that in order to do that, to express the parent relation, we need to use the parent. And first we need to put the parent. So we know Ali is the parent of Ahmed. So we want to put Ali and Ahmed. So now Ali is parent of Ahmed. And also we want to say that Mina is parent of Ahmed. So these are the 2 rules we need to add in order to add these facts. Then, using the variable C, we have this goal, parent Ahmed C returns role Philip and Gina, because there are actually Ahmed has 3 children, basically. Now we want to actually find the children of the parents of Gina, and we can find this answer looking at Gina, where Gina appears in the second parameter of a parent, and we can find that there are two hits, 12 and 13, and the parent is Ahmed and Aisha, and this actually is the result that we are looking for. So that query is basically returning the parents of Gina. Then we need to use the variable M to write the goal to find the mother of Gina. Okay, we already have a rule called mother. We need to find the mother of Gina. M is going to be the mother, and Gina is going to be the the child, and that's actually what we need to do. And then we need to write the rule to show that F is the father of C. Obviously, we don't have father; we actually define it, but we can actually base that fairly easily with mother. So the mother, that A need to be a female, and it's pretty much the same, the father, but instead of A being a female, it's going to A be a male. So this is going to be if F is a male, and if a parent, F is parent of C. There you go. Then brother is a bit more complicated. We need to write brother. So X is a brother of Y. Okay, brother must be male for sure. So first of all, we need male X. So if X is a male, and what also needs to be true in order to be X to be the brother of Y, both X and Y need to have the same parent, right? So this needs to be, let's say P is a parent of X, and also P need to be the parent of y. So now P is the parent of both x and y. So this means that x and y have a parent P that is the same. But there is something more we need to do, because we don't want that x is brother of x. So we don't want to return the value. So if I say what was the brother of a particular person, we don't want to return the same person as brother. If we do with this rule, we allow the same parameters as x and y. So we need to make explicit that x is not equals to y. Okay, so for x to be a brother of y need to be different. If that's actually what the missing part, and this is actually how a brother is defined. Okay, let's move on to question number 3. Okay, so here this question is about object-oriented programming and writing some code to define different classes. So let's have a look. We have a college with these 2 different types of students: full-time students and part-time students. All students have a name and date of birth. So let me underline the important bits here. So name and date of birth. This is actually shared across all students. And we have full-time students and part-time students. You can see that we need to provide the definition of the student, the definition of the full-time student, and the definition of the part-time student. So this actually is a hierarchical relationship. So we know that the full-time student is going to be will inherit from students, and the part-time student will inherit from students. Okay, so a full-time student has the address and also a telephone number. A part-time student attends 1 or more courses. Okay, so there's a fee that is charged for each course, and the number of courses a part-time student attends is recorded, along with the total fee and whether or not the fee is being paid. So we have the total fee, we have some Boolean value to say if the fee has been paid or not. So let's say has been paid here. And also we have the number of courses, right? Like 1 or more courses, so how many courses is going to be attending. A fee is charged for each course, so it's not specifying how many different fees, so probably the fee is the same for each course. And there we go. So let's complete this diagram showing properties and methods. Okay, so we can see that we have a student. So what actually belongs to a student? We already have student name that is actually specified here, but we also know that we need to provide date of birth. So date of birth is going to be a date time, of course, as data type. Date time. Okay, so we also have some methods here. Show student name. So I guess the idea is that for each property, we will have a show method that actually allows to show the value of a particular property. So we are going to do this in a symmetric way. So because we have show student name, we want to also have show date of birth. Show date of birth. Right, this is going to be just a method. This is a bit wrong. Sorry, let me fix the spelling here. Okay, then we have a full-time student. We already have an address. So what other fields are required in a full-time student? The telephone number. So let's actually add the telephone number to it. Telephone number, string, constructor, show address, and show telephone number. Okay, just to match the telephone number. Part-time student also have, let's have a look what we have at the top, number of courses, the fee, total fee, and if it has been paid. So let's say number of courses, that is an integer. We have the total fee, it's a currency, the type of the property, and we also have, let's say, if a fee is paid, right? And that we know that it's going to be a Boolean. Here we have the constructors, because the top one doesn't have the constructor because it's going to be an abstract class. So you won't be able to actually create an instance of a student, because a student is an abstract concept. You can only have full-time students or part-time students. So both will have a constructor that allows actually to create an instance of a particular class. The constructor, then we also have the three methods, one each for properties. So we have show number of courses. We also have show total fees, and we also have show fee paid, for example, right? And that's actually what we've been asking. Now we need to write the same definition using program code that we are going to use Python. In Python, in order to define a class, you need to use the class statement, the name of the class, student, in this case. Then we need to define the code to initialize the object. And that will initialize student name to be an empty value. And then we have the initializer for date of birth. That is empty. And then we have the methods. We have the method show student name. I think we only been asked for actually a definition, so we don't need to actually implement the methods. It is irrelevant for the question that we are asking. We've been asked. So this is pretty easy. So this is actually merely a translation of the diagram that describes the class and the actual code itself. So all the other one is fairly similar. So we're going to use Python again, similar stuff. So we have a class for the full-time student. We're going to have a constructor that init is actually, is the way to define constructors in Python. The constructor set the value of the default value for the properties. So what other properties in addition to student we have? We know we have student, the address, and we know that we have the telephone number. Let's say an empty telephone number. And then we have two additional methods, the show address. And we can actually ignore the implementation. And we know that we also have show telephone number. Okay, and that's actually the definition of the full-time students. And then we need to do some starter code. Let's say still Python. What we need to do is to create a new instance of the full-time student. So in Python, in order to do that, you can create a variable name, and the identifier need to be called, as you can see here, new students. So let's create a new students equals, and then you actually use the class name to actually construct it. So full-time students, like that. So this actually will create a student, but we need to actually set the name, the date of birth, and the telephone number. In order to do that, we need to actually use the dot notation. Your student dot student name. How we call it? Student name, yeah. So student name equals, and we actually been asked to add the a dot 91. And then we have new student dot date of birth to be 12/11/199, and then we have the telephone number to be 099111. Right? So this is actually pretty easy. You just need to set the properties values with the values that you've been given. Okay. Question number 4. The question number 4 is about abstract data types. We have basically a dictionary, a method create dictionary that defines an additional an operation called add that allows you to add the key value pairs, delete key value pairs, and also find for values, the lookup. The dictionary is implemented as a two-dimensional array. So we have basically two arrays, and one to store the keys and one to store the values. And we need to actually define the hash function that is used to basically find the location in the array where a particular key value pair need to be added. Okay, so that's the idea. How dictionary works is like that. So you've been given a key, An hash function is used to calculate a number, and this number is actually the location where the value will be added, the key and value will be added in the dictionary. Okay, and that's actually why the dictionaries provide this very quick lookup and addition and removal of values, because it's just a linear function calculates the location of the key value pair in the dictionary very quickly. Okay, so we actually been given what algorithms we need to write. So what we need to take first is the key. So the hash function will accept the key, and the key is a string, we know, and we know that it's going to return an integer. That is the index in the array where the key will be added. So this will be an integer. Okay, what is the algorithm that we need to do? So we declare a number as an integer, and of course we want to return this number, so we need to just return this number. So how we calculate this number? This is going to be actually the index. We need to extract the first letter of the key, and we can do just doing like key 1 like that. So we get the first letter of the key, and then we need to calculate the position of the letter in the alphabet. That is ASCII. So we need to find the ASCII key of this key, and then we need to actually subtract 74 because we need to remove the ASCII code of A. That is so we want A to be 1. Okay, if we remove 64, because A is 65, the subtraction will be 1, and that's what we want. So we want to store a key with value A in location 1, and that's actually how we can write this algorithm. So the hash function extracts the first letter, return the position of this letter in the alphabet, and then yeah, and that's basically it. Considering capital letters. Okay. The next question is, okay, so we have the algorithm for adding a new key value pair to the dictionary. That is basically calculating this hash, get the index, and then set the new key and the new value at the location index in the two kind of in the two arrays, in the bidirectional array, basically. Not bidirectional, sorry, in the multidimensional array. So in the dimension 1, we store the key, and in dimension 2, we store the value. So we basically have a bunch of additions, and we need to provide the content of the dictionary after all these additions occurred. So basically, we need to follow this program and see what happens. So the first statement is add file date I. So we take file. We know that the algorithm to calculate the hash takes the first letter of file, that is an F. And where is the location of the F? What is the location, the number of the letter F? So A is 1, B is 2, C is 3, D is 4, E is 5, and F is 6. So we know that we need to add stuff at index 6. So we know that we need to add the key, that is file, in location 6, and we know that we need to add the value, that is date I, at the same location in the second dimension. And we can do the same logic for the others. So disk D, disk start with D. D is the location 4, so we need to add D. Disk at the location 4, and plat at location 4. Error is instead start with E, that is a location 5. Then we need to add this error here, and the value is failure. And then finally, computer, C is a location 3. Then it needs to be saved here. And then we have Rechner. Okay, and that's actually the result of the dictionary after running these 4 additions. The next question is asking what a possible problem that can occur when the key value pair is saved. Okay, so if you add the drive and Lufkerk, the problem is that drive start with D, and we already had that an item in the dictionary that with a key that start with D, that is disk. So the location in the dictionary at index 4 is already taken. But if we do not change the program that actually add the the element in the dictionary, what happens is that drive will override disk. Okay, so we're gonna lose the element disk and plat. So let's put it in words. Basically, a collision occurs, and the previous key value pair in our example is disk and plat gets overwritten, basically. Occurs. Okay, a collision occurs. Okay, that's what happened. Then you need to describe a method to handle this problem. Okay, the typical approach in order to solve this problem is very simple. So if you find that the location at the index, the particular index that is calculated using the hash function is already been taken, you scan through the dictionary. So you move to the index +1, index +2, and so on. Like for example, let's say we get index 4, and we see that this is full. We look at the next location that is 5, and this is still full. We look at the next location that is 6, is still full. Let's have a look at the next location that is 7. Okay, now this is empty. Let's add it here. Okay, so basically you scan through the elements starting from the location at the start location called base location, and then find the first free location in the dictionary. And that's actually a typical algorithm that is used to solve this problem. So basically, save the overflow record at the next available address in sequence. Don't say that. Okay. And then we need to write the pseudocode that implements basically this solution. We have been given already the statement, the code that describes the addition. So what we need to do, what we need to change is that basically we need to, before adding new key and new value to the dictionary, we need to change the value of index if the position is taken. And what does it mean if it's taken? It means that the location in the first dimension in the key doesn't. If it's empty, it means that is not used. So basically, at location 21, let's say. So basically, straight after the assignment to the index, what we do is we do a loop. So loop in the dictionary. So let's have a look at what is in location index at in the dimension 1. And if this is different than empty, right? We know that is already been taken. So we need to move on to the next location. So this is going to be this is actually pseudocode. So let's do that. Index +1. Okay, so we move on, but we know that we have a certain number of locations. So the size of the dictionary is not unlimited. We know there are how many? 2,000. Let's have a look. We have a dictionary of 2,000 elements. So we know that if the index goes above 2,000, we need to get back to 1. So if the index is greater than 2,000, then index gets set back to 1. And then we do an end if, and then we do an end while. There we go. So this basically is the code we need to add before assigning new key and new value. Excuse me. So let's move on to the next question. That is about some assembly code. All right, so we have some instruction loading the number to the accumulator, doing some direct addressing, storing the content of the accumulator on a particular address in memory, addition, increment, comparison, and jumping. We have some piece of assembly language, and we need to actually dry run it. So that means that we need to actually put the values in the memory and the accumulator, how these values change as you run the program. So let's try to do this. Okay, the first statement is load 512. So what does it mean? It means that we look at the location 512 in memory and load this value into the accumulator ACC. So at the location 512, we have 0 as value. So this means that we actually set the accumulator to 0. Because the accumulator doesn't have a value at the moment, we can just set it here in the same line. Okay, so we start from here. Then we move on, and we have the second statement. Let's see if I can. Yeah, no. Just want to avoid scrolling too much, but yeah, it's right. So let's see if I can put the view like that. Yeah, so maybe it's a bit easier. No, sorry, doesn't help. So so we have this program here. So sorry. The next statement is the addition. Okay, we need to do add 509. So what add does, you can actually read what it does here. So add the content of the given address to the accumulator. So we need to look at the address 509 and add it to the accumulator. So 509 contains 7. We need to add 7 plus the value of the accumulator 0, and the new value of the accumulator will be the result 7. Okay. Then the next instruction is store 512. So this means copy the value of the accumulator at the location 512. So because the accumulator is 7, we set 512 with 7. Then we move on. We do load 511. 511 contains the value 0, so this means the accumulator will get back to 0. Okay, and then what we do, we add the 509. So 509 contains 7. No, sorry, I missed something. So we are at 503. So then we increment the accumulator. That becomes 1. Right? Then we are storing 511. So we are at the 6th instruction. So this means that we copy the value of the accumulator at the location 511, and 511 will basically contains now 1 because we copy the value 1 into it. Then we do a comparison 510. What this does is look at the value of the accumulator, compare it with the value at the location 510, and then the next instruction is, if the two values are different, goes to 500. That means jump back to the beginning of the program. So basically, this is 500 here is the location of the address of the memory where this code is loaded. So the jump statement basically say if the result of the comparison is different, so the two values are different, jump to 500. Otherwise, carry on. Okay, so let's have a look what we need to compare. So we compare the value of the accumulator with 510. 510 contains 3. 1 in the accumulator is different than 3. Yes, so go back to 500. Okay, and what 500 does? Load 512. So basically, load in the accumulator the value at the location 512. In the location 512, we have 7. So basically, load 7 back in the accumulator. And then we carry on with the same logic. What we do after the load, we do an add of 509. So we look at 509, there is 7. We add 7 to 7, and then the result will be 14. Okay, and then what we do, we store 512. So we store the value of the accumulator 14 at the location 512, and this has become 14. Then next, we load 511. So 511 contains 1, and we load 1 back to the accumulator. Then what we do, we increment the accumulator. So this becomes 2. And then we store the result of the accumulator at the location 511. That is going to be here. This becomes 2. And then what we do a comparison between the accumulator and 510. 2 and 510 is 3. So 2 is different than 3. Yes, go back to 500. And what 500 does? Load 512. That contains 14. So load 14 back to the accumulator. Then what we do add 509. So we add the value of the accumulator 14 with the value of 509. That is 7. 7 plus 14 is 21. You can see that we actually trying to do the multiples of 7. 7, 14, 21, and so on. we are 21. Then after that, we do a store 512. So we store the value of the accumulator in location 512, that is 21. Then after storing that, we load 511 in the accumulator. 511 contains 2. Now, this is going to be 2 now. Then we increment the accumulator again and becomes 3. Then what we do? Then we, after loading that, we store in 511 the result that was going to be 3. Then we compare. Then we compare with 510. The accumulator is 3, 510 contains 3, so 3 is different than 3? No. And we carry on, and then we end. And this is actually the tracing of the program, okay? Yeah, it's quite laborious. We need to be careful when you run this, so I suggest you, now a bit of back and forward, sorry for this, with the PDF, but if you do it on paper, you try to, keep your pencil at the location where the program currently is, and then you kind of change the value as you go. So make sure that you always execute instructions in order. Okay, then explain the role of the address 511 in this assembly language program. So what we did, if you look at the program, what actually produced is 21. That is 7 by 3. And you can see that if in location 510 we have 3. So basically we are counting 7 3 times. We find 7, 14, 21. So we kind of count, somehow we are kind of producing 512 at the location 512. You see at the end of the program, 512 contains 21. That is 7 by 3. We're doing the multiplication of, we're doing the multiples of 7 at position 3. And what 511 contains is actually step by step all the results. So it's kind of a count variable that is when you do like in Python a for loop, is the I, is the variable that contains how many times the loop has been executed, right? While 510 is the terminator. After this variable reaches the value at the terminator, we stop, and we actually have in 512 the result. Okay. So 511 is basically, it stores a counter that control how many times the loop has been executed. Yeah, it's basically the loop variable. Then what you need to do is, using the ops code from the given table, write instructions to set the value at the address 509 to 12. Okay, so we know that when we use assembler that we can't do this instruction in a single operation. We need to do 2 operations. First, we need to load the operand into the accumulator, and then we need to store the result to a particular address. So we need to do first an immediate addressing, a LDM of the value 12, and then we need to do store using the address that we've been given. So the first instruction we need to do is LDM, and then we need to load 12 like that. So now the accumulator contains the value 12, and then we need to use the instruction store, passing the address where we want to copy the value of the accumulator into. And this basically set the location at address 509 of the memory with the value 12. And there's always 2 instructions to do this using these particular instruction sets. Excellent. So now we move. I think now we change gears, and we have. Sorry, I'm trying to reconcile here where we are. So I moved too far. I skip one question. That is 6A. Okay. So we have a files. Okay, back to files now. We have a company keeps details of its stock items in a file of records called the stock file. The record fields are the product code, the price, and the number in stock. We need to write the program code to declare the record structure stock item. And we need to use, let's say we use Python again. It's our favorite language. So we can use classes to do that. And classes is perfect because it allows to aggregate different values together. So let's create a class called stock file. This is not that different of the from the exercise we did before. So we just need to do the definition and provide a constructor that initializes the possible fields. So we basically use the class as a record. Self.product code is one of the first things. We can use a string for that. Then we have what else? The price, that is going to be, let's say, 0 by default. Let's say this is a decimal. And then we set the number in stock to be 0 by default, right? So that's it. So it's a class with 3 particular values that are not just simply initialized. Then before records can be read from the stock file, the file needs to be opened. Okay, so we need to fill this pseudocode. We see that we use a try catch, try except in this pseudocode statement, and we wrap an open file statement. So open file basically is the instruction in pseudocode that open a file, and we want to actually open the file for read, for example, for reading it. So what we need to provide is the name of the file, that we know that is going to be a stock file, and you need to provide for what you want to do this. Let's say we want to actually read it, right? We want to actually read from the file, because we say before records can be read from the stock file, we need to open the file. So we open the file for read. But this operation can fail. And if it fails, we can just, for example, print an error message. It's quite common. So instead of actually crashing the program, we just print an error message. And the error message is called, let's say, the file does not exist. That's a kind of typical error that occurs. If the file is not present in the file system, open file will throw an exception. We capture the exception, and so that we don't fail the program, and we just print the error message to the console. And explain the reason why lines 1, 3, 4, and 5 has been added. As I said, this is basically a try statement that check for possible runtime exceptions. When you run the program, if the file doesn't exist or there is an exception that occurs, we capture it and we handle the exception, and then we print an error message in order to avoid the program to crash. It's absolutely critical that we do this kind of checking so that the program is actually robust. So the try statement, check for possible runtime exceptions, and the except, handle the exception and print an error message to avoid the program crashing. Okay. Then the last question. Yep, the last question is, we have a stock report program use a variable stock item declared as follows. So we create an instance of the stock item called this stock item, and the program reads each record in the file in turn, and then we just print the code and the number in stocks. So we need to write pseudocode. Okay, so what we can do here, we can just, in order to read the file till the end in pseudocode, we can just do a while loop until end of file returns false. So we need to do a while loop is not, and then there is EOF. It's quite a common function to use. That means end of file. You pass the name of the file like that. So EOF will return true if we finish the file, we actually complete the file, and if it's not, then the while will carry on. So if end of file return false, that means we haven't finished to read the file. The loop will continue. And what we do, we use the read file function to actually read a particular record from the file. We provide the file name and comma, and then the name of the variable that we want to use in order to actually read the record. And then we use the output instruction to actually print the value on the console. Dot product code. So we want to print the product code, and also we've been asked to print the number in stock as well. So output this stack item dot number in stock. And then we need to remember to actually close the while loop using the end while. There we go. So this is actually the end of the paper. So I hope it was clear, my explanation. If you have any questions at all, just send me an email at angela.andrea@gmail.com, or just write the question in the Slack channel of the school. Thank you very much for watching, and happy coding.